Network just to have a network. You build it to have devices, to have software, to automate your processes, as we've seen with Blizzard and others. So really excited today. A number of the Anterix Active Ecosystem members are here to display some of the products we have. I'm going to call Jim Lee, who is Director of Engineering with Anterix, up to the stage, and he's going to lead us through these demos.
Hey, thanks, Mike. Hey, as Mike mentioned, members of the Anterix team is here. So if you have any questions or any comments about the ecosystem in general, we talked about a lot of it in the panel today. Both UBBA and on the Anterix side, we'd like to talk more about it, right? We have lots of vendors here. We have lots of utilities here as well. Any questions, run to our table, ask about it, all right? So as part of the engineering team at Anterix, right, we do a lot of things with, you folks here. We've worked with a lot of people. I know a lot of you here. And so what we've developed in our New Jersey facilities is this private LTE system. Obviously, we have 900 megahertz running over 900. But the key point here is that we're running a private LTE system, right? And we've been able to work with the various vendors, various utilities, understand what their use cases are. And we've taken a sample of those use cases and actually implemented it right here. It's orange pegboards that we've actually implemented them. There are labels on them, some of these use cases. But before I go into in depth of what you see here, I have a couple slides, so maybe you can advance, right? Because I mentioned private LTE, right? Private LTE, most of us, think about LTE consumers, right? You grab a cell phone, Verizon, AT&T, whoever you use, right? And that's LTE, right? It provides broadband coverage. It gives you access to email, YouTube, whatever you want to do, right, from a consumer perspective. But what it doesn't give you access is the private side of LTE. So private side of LTE is basically one of the concepts is quality of service. And I guess, we've talked about this, maybe in the next iteration of Plugfest, right? We're going to go dive into, say, quality of service and do a lot of use cases there and a lot of plug testing there, right? But a flavor of it is just conceptually, if you're a private enterprise, right, and you're running a distribution network, say, we talked about earlier this morning, fault line Flizzr, right? Flizzr, we talked about it. It's a very critical use case. We talked about fault line protection, SDG&E, and Schweitzer technology. They have to be able to detect things with a high degree of resiliency and criticality, low latency, high bandwidth, those kinds of things. And so QoS is part of that because you have other use cases, say, you're doing distribution automation or you're doing some metering, which doesn't require that criticality, right? 1-day pulls, 15-minute pulls, whatever, right? So you have the ability at the wireless level, at the LTE level, to actually tag qualities of service to different types of traffic. So if you think about an IT system, right, or an OT system, end to end, you have your routers, you have your head end. You can do that today, right? You can tag it with DSCP. You can use more sophisticated MPLS structures, for example, to do that. The missing link before, if you go through LTE, was you couldn't do that, right? It was just best efforts if you're using consumer cellular type. Private LTE, because the enterprise or the utility owns it, right? You can actually now tag your service tier on top of LTE QoS, right? It's called QCI, right? So there's a whole standard on how to implement this. So, and we've implemented some of this in our test setup in Jersey, right? I'm not going to go through all those presentations today, but like I said, in the next Plugfest, we'll talk about how QoS is implemented, how things can be traffic shaped and load balanced, right? For today's presentation, I'm just going to give another brief summary here. Maybe we can move on to the next slide here. Again, just another focus on why private LTE is important, right? So we talked about QoS, the control you get, traffic shaping, optimization, optimizing your network traffic, including the wireless. Security is another big factor here. So we talked about this morning, right? What is that you can do now because it's a private LTE system? There are basically, and there's a lot in there. It's meant to be a busy slide. There's so many things you can there to improve or or enhance your security of your network by implementing these. But basically 3 segments, right? You have the network layer. So there are certain things that you do probably today, VPNs, what have you. You can also implement them at the wireless LTE level, right? And then there's the user data levels. All the stuff's highlighted in yellow, for example. You can also implement additional layers. But the key aspect here is the one in green, right? As an OT or an operations within your, your network now, before, if you were just using LTE, you didn't have this visibility. It's best efforts. Now you have the visibility into every one of your network elements. So you hear a very basic end-to-end diagram of what LTE is. You have your core, right, which is connected to your data center and your other head-end applications. And of course, you have the wireless elements, the ENOBs. And of course, at the device level, you have the devices, the UEs, they call them. And because now it's your private network, you actually have the visibility into its availability, right? You can trend over time, see how resilient it is. You can make decisions ahead of time and proactively optimize your network. So this is another key differentiator for private LTE. So one last slide, and basically the last slide is just an end-to-end diagram of what this network system is that we have in New Jersey, what we're presenting today. So here you see 3 pegboards, and I'd like to, after I 2 more minutes here, I'll introduce you to 2 of the vendors that are here. One is Honeywell, the other one's Automation with their products, and they'll go into further details, and we'll actually demo some of their capabilities here today. But in general, so we have 3 pegboards here. As we know, LTE is multi-device functional. What I mean by that is you have LTE devices that support the higher bandwidths, but the coverage isn't there. And then you have Cat-M1, which is an IoT type technology. You have better power savings. You have better link budget in terms of coverage because of how it's designed. And you have narrowband LTE. So here we have all those on display. Today we'll focus on Cat-M1 devices, which are IoT devices. So any questions before I introduce Honeywell to come up here and do their demonstration? Cat-1 or Cat-M1? Okay, yeah. So Cat-M1, there's a few differences on the physical layer. So as you know, LTE is anything from 3 megahertz, 5 megahertz, 10 megahertz, 20 megahertz, those types of bandwidths, right? Cat-M1 is 1.4 megahertz. So the bandwidth uses only that much resource blocks in order to transmit. But of course, on the device side, because of how it's designed, you can use lower power, right? So it's designed to last up to 10 years, depending on the device, right? But it's also designed with lower throughput in mind. So applications like metering or something that just pulls once a day, right? That's the type of, it's an IoT type application. Same like NB-IoT, for example. NB-IoT is a little bit further in terms of its bandwidth. It's only 200 kilohertz. It can operate inside of a LTE, band or system as well. And of course, it also has further savings in terms of power and coverage as well, or building penetration loss. So that's from a physical layer, yeah. Oh, Rob, why don't you come up? Rob is from Honeywell. I'll let him introduce himself. And I think he's got a set of slides as well. Thanks.
Thank you very much. Oh, right there? Okay. Well, I guess I'll try to remember what's on the slides. Can everybody see me? Okay. Okay, so just real quick, Rob Hartway, Honeywell Smart Energy out of the Raleigh office. I lead technical sales and solution architecture for the Smart Energy group at Honeywell. As just said, we're very excited here to show you for the first time ever a smart meter operating on a private LTE solution. But what I wanted to do just really quick too, knowing that there was a relatively kind of broad audience here, is I did have a couple slides. I'll try not to bore you, but just kind of bringing up the history of metering and cellular metering specifically, and kind of what brought us to this stage. So, oh, no, go ahead. Yeah, so go ahead. So this, obviously generic architecture, don't worry about the specific details, but as we walk through it, so, any AMI system, whether it's Honeywell's or anybody else, there's a suite of software applications that make up the AMI head end, and then they interface with the utilities back office systems. And if you advance one more time, now today, most all AMI solutions, all AMI solutions are operating on a mesh, right? So you're literally just using that WAN backhaul, either fiber Ethernet or, we don't have that cellular, to some sort of router that is managing that subnet of mesh devices. And only an exception if you advance once more. And it's really just, So only in certain cases are utilities really using direct connect to the meters, whether Ethernet or cellular. Now, historically speaking, and I can go back and, first using Ethernet and cellular over 20 years ago, but it was really the exception to the rule. I mean, it was very costly and for a lot of other reasons. So we only use cellular to direct connect if we really had to, whether it's we couldn't get mesh into it or that particular application like a large industrial plant or something else wanted a whole lot of data a lot more frequently. Now, however, though, as as I was just saying, that has really changed. And this latest set of technologies really is what done that. So, And don't worry about that. That's Han, so probably should have deleted that one. Don't want to confuse people with all the other lines. But if you advance once more, so what has changed? So firstly, like if you look certainly over the last 20 years, but even just the last couple of years, a cellular connected meter was a lot more expensive than a mesh-based meter. And I'm not talking 10% or 20%. In some cases, it's 200% or even more. Obviously, that for one is going to limit the use. But in addition to that, even if you could swallow that painful pill, data plans with the public carriers were pretty outrageous. So they were still trying to charge rates very, very similar to the rates on a cell phone. Which of course is going to destroy a business case, except for those couple of examples. And there was a lot of other things too earlier on. Didn't quite have the cellular coverage. In certain cases, a lot of the towers didn't have backup, failover, redundancy, things like that. So there was some kind of reliability situations, and certainly in certain cases. And then also, as a lot of you utilities may have seen, was that longevity commitment. And that you're concerned that the public carriers say, hey, you know what? I'm going to turn down that 2G or 3G service 10 years earlier than I told you I was going to, and that's very, very frustrating. Again, so there were some other things there as well, but really, all that has changed, or I should say there is a solution to all that. And that inflection point, sorry about that. And that inflection point has really happened very recently when finally the industry and the chip makers, realized that we really have to branch away and not just try to have all technology, fit that one path of cellular chip, advancement, like they're doing for high broadband, smartphones and everything else, where you're just talking faster and faster and faster speeds, really don't care about cost, really don't care about power consumption. And so with that creation of that parallel path of chipsets specifically for machine to machine, which I guess officially started with Cat 1, but really it's Cat M1, hence machine for M. And that's the first time where now we have a chipset that is significantly less expensive, therefore making it price competitive to mesh and other solutions, and at a much lower power, which for an electric meter is not as big of a deal, but if you have gas or if you have water or other battery operated devices, you have to have something that's really, really energy efficient. But in addition to that, part of the great part about that is you can have, with a lot higher radio sensitivity and everything else, is to be able to get incredible range compared to other cellular technologies that you see there on the top. And yeah, there's a little bit of a trade-off, and I mentioned down there on the bottom is lower bandwidth and higher latency compared to my latest iPhone. But compared to mesh and other capabilities, we're still talking an incredible amount of dedicated throughput and an incredible low latency. So compared to other technologies. So if you go ahead, yeah, and this is again just a little bit of a summary, and he had talked about this, but So cellular, you've got that licensed spectrum. I'd mentioned a little bit about the long range, and there's a number of factors that go into that long range. But what we've already experienced here, through our testing and initial deployment of Cat M1 on public, is we're able to get as much as 5 times the range of other cellular technologies, in addition to, which is about kind of the 5 times the range of over most mesh technologies as well. And in cellular in general, you have that unlimited scalability, right? So starting with public, you don't have to go out and build that network. You can go out and pop in that meter, and it's going to come on right away. And so there's a lot of that benefit too. And I mentioned some of those other things. But as also mentioned from a utility perspective, and former utility employee myself, of course. So you love that, that control, that ownership. If I own that cellular network, I have complete visibility, I have complete management of that network, complete control of that network, and control over costs. I don't have to worry about data overruns and things like that. And then, the last one, I kind of threw it in there, is, talking about range even more. So you have the standard modulation, which is mode A. There's an optional mode B that you can implement right away on private. On public, you're gonna have to wait until the public carriers implement it, and ultimately they will. But that gives, almost potentially 2x the range and penetration. Now, of course, what we did is we worked with chipset manufacturers, specifically, and finally tuned that, as well as custom made the antenna in here. And so in addition to that, we're seeing about an additional 2x range over just off the shelf, if we were just taking off the shelf Cat M1 and put it in there without any other modifications. So again, like we're really, really excited about the throughput, the performance, and again, when operating on gas and water, also, which we support, being able to get that 15, 20 plus year battery life on cellular. And if you do, sorry. Yeah, go ahead and advance one more. Yeah, okay. Yep, no problem. So I won't talk much more about it, but we chose obviously our latest generation of meter to put this technology in. And again, it's I won't go into the details, but it's a super cool meter. If you advance one more, I'll just and I have to, since technical sales, I have to do my little pitch. So these meters, these 4th generation meters that we call the Alpha 4, every single meter, whether it's Form 2S residential all the way up to a CNI meter, full functionality. Every meter, is bidirectional, net sum, 4 quadrant, 5-tier TOU, 12 season. Every single meter has multiple demands, up to 18 channels of interval data on residential, 40 channels on CNI, 1-minute resolution. Complete set of power quality management tests that are individually selectable and configurable, as well as SAG swell. That's all great and dandy, but that also means that's a tremendously huge amount of data that you're going to be pulling back, that can burden even some of the best mesh networks. But with the dedicated throughput that you get here, that's not the case. So I think that might be my last. Yeah, essentially my last slide. So this is obviously a summary. Best technology. Obviously, highly scalable, extremely secure, et cetera, universal standards with 3GPP and giving you that longevity, being able to then, all the way up until through the operating even on the 5G networks, et cetera. Great range. And as I mentioned before, specifically for the battery operated device, 20 plus year life. So with that, again, demos are demos. Everybody knows that meters can be read over the air and everything else. So not going to spend a lot of time. But what I did want to do is have you guys see, the first operation of turning on and off a load over a private cellular network. I remember 20 years ago, the first time we said, hey, we did it live, and again, that was 20 years ago. But this is the first time ever on a private cellular network. So, and I know it's not too exciting, but I'm going to go ahead and log in and just perform that operation. Yeah, no, that's a great point. Thank you. Yes. Oh, sorry. I'm really scaring people this close. But yes, it is. So the meter is completely configurable, programmable, upgradable, everything else over the air. And in fact, so like you said, whether that's first deploying with the public and then moving it over to the private once you've built it, or like you said, with that change in the back end architecture of that, that can all be managed exactly remotely, so you don't have to go back out. Yeah. Oh, yes.
I'm just going to add some enhancements to the answer, right? I mean, so if you look at LTE, it's 3GPP standards, right? So you have the three vendors behind us, right? Nokia, Ericsson, and Motorola presenting their 900 megahertz spectrum, right? The devices, as we talked about, this is a Cat-M1 device, right? If down the road you wanted to deploy a meter that happens to be narrowband LTE or LTE, because it's part of a 3GPP standard structure, it'll all operate with whatever ENO-B that you're talking to. So you can actually, have a mix. Let's say you deploy these meters 10 years down the road, there's an improvement Honeywell comes up with, and they use a different technology. It's LTE. You can also deploy that without taking this out. So operationally, you can continue with your operational flows. No, that's not my point. Yeah, you can't over there change it. That's maybe it's some other technology, but you can deploy other technologies if you wanted to. So yeah. Right. So the point here is that the base station, as they advance, right, it can be 5G, but everything's backwards compatible, and you can actually operate Cat-M1 devices, narrowband devices, other category LTE devices in the future. All right, back to you. I'm excited to see your demo.
Well, the demo is a press of a button, so it's not going to be super exciting here. But yeah, I mean, the point being, what I was going to say is another change that has occurred. Well, I'll tell you what, I'll go ahead and do it, and then. But so the point is, going in and telling the system that I want to disconnect this. And of course, are you sure? Are you sure this is a really nice person? But realistically, this is going into the head-end system, and okay, that was super exciting, wasn't it? Yay! First time ever on a private network, and you were here to see it. But one of the big differences too within the industry is earlier in the early generations of AMI, the AMI system had a big responsibility. It had schedules. It reached out and pulled information from all the different meters based on schedules and everything else. Well, now that the meters are a lot smarter and a lot more intelligent, that whole scheduling is now in the meter, right? And each meter can have its own schedule, and it pushing different data sets at different frequencies. So in today's AMI systems, 99% of all the meter data, it's being pushed on a predetermined schedule. And so the only head-end operation down are things like this, when somebody move in, move out, that type of operation. Okay, and I've been told I'm out of time, which is great because I'm done. So thank you, everybody.
Thank you, Rob. All right, I think we're actually running pretty close on time here. I see Guy back there from automation. As he walks up here, I'll just give a quick introduction. This is the other Cat-M1 device that we want to demonstrate today. It's a pull sensor, right? Running over private LTE as well. And so he'll come up and give us a talk about it. Okay, I'm being told we only have 5 minutes, so.
All right. Oh, all right, but I put my mobile phone over here. And you're gonna run the slides, okay? Not yet. Hi, everyone. My name is Guy Weitzman. I'm the co-founder of Automation. We're two co-founders. We're based out here in St. Louis, so it was only a 15 minutes drive for me to come here. And I will present our technology. As Jim mentioned, we have edge computing technology, IoT device that goes on poles. We're going to focus on that device, which there is a cool demo here. You can tilt the pole, you can shake the pole, you can impact the pole, whatever need to do. This is an edge computing device, so it's including inside the cellular communication up to the cloud. It's an end-to-end platform. There are sensors inside such as vibration, tilt, impact, EMF, temperature, humidity, and so on. It's a standalone device, so you just install it on the pole. It has a 7 years battery lifetime. If you look at the lab, we can even get to 10, but that's how we sell it. It's just a device that you place it, and everything from software perspective communicates to a mobile app, to a dashboard, and there are also RESTful APIs if someone wants to pull the data into a third-party platform. So what I tried to do, I have just a couple of slides. I wanted also to get some picture from real installation in the field. The automation edge computing enables utilities company. Usually we see three main use cases. It's either, like Jim mentioned, to monitor a pole. You can monitor aerial cables on the top of a pole. And we see some cases where utility company install it actually on the transformer, because based on the vibration and the heat of the transformer, you can also gather data and get alerts. The way the system works, there are two options on the edge computing. The first one, it's the obvious one. You have the option to upload data based on sample time. So you can tell the device, hey, I want you to sample every hour, and you will upload data for 7 years divided by 1 hour. I don't know the results right now in my head, but it's going to be lots of data. You can do 12-hour, 24-hour. Everything is configurable from the mobile app or from the web portal. Another option, and I think that's where it's come more advanced, is there is an option also to set thresholds. That means that only when something exceeds the threshold, let's say the temperature goes above whatever, 140, that's where the device will wake up and send an immediate alert. It will communicate and send it, including text messages and email to the relevant people that needs to know about the problem. So the idea of edge computing, what I'm trying to do, unlike SCADA and other platforms, most of the brain, all of the brain, I will say, it's over here, and only when something goes wrong, that's where the device wakes up and starts to communicate, and that's why the lifetime of this device is up to 7 years. We like to create a family, so this is one device, but it has sibling, mother, and a father. So there is other setup options. For the utilities companies, it's very recommended to use this specific device that I'm holding right now. I'm going to create a tilt right now, so we're going to see it on the dashboard. So basically what's happening right now, I set up the device, hey, if you move more than 15 degrees, we need to get an alert. Assuming I'm doing more than 50 degrees, and even if I want to do more, I can't. It's stuck, but that's the degrees. And anyway, what's going to happen right now, that if the sensor, the code is waking up, detecting the 15 degrees, sending the information up to the cloud, to the dashboard and the mobile app. And once I'm going to release it, let's say it moved back, again, he will say, okay, I'm back to norm. He will send again an information. So basically, what it means that everything that happens on the device will communicate directly if there is a problem. On the other hand, if everything is okay for 5 years, so the device will be quiet and just will send a day or twice a day or every hour, just the sensors values, so you can see that everything is communicate. It's a bi-direction platform, so you can, on one hand, send information from the device up to the cloud and so on, and get some analytics and so on. But also, there was a question about over the air and stuff like that. So you can also push to the device configuration and new versions. Okay. Okay, so we are short in time, so I prefer to leave time for questions and then we can go and show the dashboard. Okay, we don't have too much time, so it's a very, very user-friendly dashboard, okay? So as you can see, the main dashboard shows exactly where the devices are. So this is the Anterix account, so there is one in New Jersey and there is one over here, okay? On the right side of the device, those are all the events I was doing while we were talking, and it gives you the event and the time and so on. But the most thing that I want to show you over here, because we're lack of time, as I said, everything can be exported to any given platform. So you can either export it locally to your computer and do some more analytics, or you can just export it with our RESTful APIs. And of course, there is a way also to consume more advanced analytics, such as to see some graphs, behavior, to compare sensors to sensor, and so on. And this is about it. So if you still have, we still have some time and someone has any questions, so you're more than welcome to ask. If not, I'm gonna be here around. We have device here, we have device in the other room as well, and we can talk about it.